All right, folks. Mr. Kowalczyk here. Today we're going to do Geometry Unit 10, Lesson 5, Trigonometry Ratios. Now, I just got to start out by telling you that I feel really excited about this. I'm a little bit nervous, but mostly excited. This is a very big lesson. Not big in terms of size and time, but big in terms of its importance. So really, please, if your teachers haven't told you, take time, turn everything else off, just avoid distractions for the next 10-ish minutes, 15 minutes, and please pay attention to what we got to do today because it's a big lesson, really important, and I want you to get as much out of it as possible. So without that, let's jump in. Also, the other thing about today is that you want to have your calculator handy. If you don't have your calculator, please get one. This TI-30XS is the best one you can get for the money. It's cheap. It has lots of different functions that are going to help you out. So please get one. It's really going to help you out. All right, now we got theta. Sorry, let me back up a sec. What do you notice about the relationship between these three triangles? I'm so excited I just jumped in. What do you notice about the ratio between the left side of the triangle and the bottom side of the triangle? So just check it out for a minute, see what you notice about those, and then we'll come back together and figure that out. All right, here we go. So for the first one, I want to point something out here. This little symbol right here, that's a Greek letter, and that is kind of written like this, and it stands for a Greek letter called theta. And theta basically means an unknown angle. So just like we use X for our variables, our unknown values, theta is going to stand for an unknown angle. So that's a new variable that we're going to use that you haven't seen before. One of the new things we're going to learn today. Now, if we look at the 12 and the 24, that's what we're being asked. Notice about the ratio between the left side and the bottom side. So 12 to 24, that's the ratio that we're talking about here. That's reducible to 1/2. 10 over 20 is equal to 1/2 also. And 8 over 16, as you probably notice, is equal to 1/2 as well. Now, what else can we notice about these? Well, we can notice that they're similar. We have 8 to 16 being 1/2, 10 to 20 being 1/2, and 12 to 24 being 1/2, and they all include this 90-degree angle here. So they're all similar by side, angle, side. Similarity. So that's really cool because they're just shrunken down or expanded versions of each other. Now this angle theta here is the same angle in all three triangles. So what we can assume from that is that we know from our definition of similarity that these three angles have to be exactly the same. They got to be congruent in each one. So when we have a ratio of 1/2 here, or any ratio that's the same in similar triangles, the angles are going to be the same. Now that's really helpful because in today's unit, what we're going to be doing is we're going to be talking about how these work out. Now, we've got ratios in each of these triangles that are right triangles that are going to come into effect. And this is the second new thing that I'm going to teach you today. So the trigonometric ratio, which is our whole idea for today, the first one that we have is sine. That's our first trigonometric ratio. And the ratio in this case is going to be the opposite side divided by the hypotenuse. The second trigonometric ratio is cosine. And that's going to be the adjacent side, I'll show you what I mean by that, divided by the hypotenuse. And the third ratio is going to be tangent. Now these are all three new words that we're learning today: sine, cosine, and tangent. And the trig ratio for tangent is going to be the opposite side divided by the adjacent side. And again, we'll practice this together, okay? We got lots of time to practice this. Now, when in this box here, when I say perspective matters, what I mean is that it depends which angle you're looking at, right? We know that this is only true for right triangles. We've got a right angle here. So we know that we've got two other angles in this that we're really going to pay attention to. So in this case, what I'm going to say is that if I'm standing at angle A, or if I'm looking from angle A, we'll call this angle theta. So then we have sine of theta, cosine of theta, or tangent of theta. That if I'm looking from here, I have to label the sides of my triangle, similar to how we did in the 30, 60, 90 and the 45, 45, 90. Now, all right, let's think about this. Well, we know we have the opposite side, we have the adjacent side, and we have the hypotenuse, because those are the sides that we used in our ratios here. Well, the hypotenuse isn't going to change. That's always the one that's across from the right angle. Great, that's an awesome place to start because that one does not change. But if we're here at this angle, what's the opposite side going to be? Well, that's going to be straight across the triangle, this side right here. So side BC is our opposite side when we're looking from this angle. And that only leaves us with the other side, which is adjacent, which is one of the sides that makes the angle. That's the adjacent side right there. Okay. Now, I'm going to use a different color, and I'm going to show you, let's say we have a different angle, this one up here. And I'm going to use this in red. And this one we're going to call phi, which is another Greek letter that can stand for an unknown angle. Now, if we're at phi and we're looking for the hypotenuse, well, that's not going to change because the hypotenuse is always across in the right angle. That's not going to change either. But if we're here at B and we look at the opposite side, then this side will be considered the opposite. And this side here is going to be the adjacent. BC is going to be the adjacent. That's why perspective matters, because it depends on which angle you're looking from. Are you looking from angle B or are you looking from angle A? That's what's going to be really important about this, okay? All right. Now, when you use trig ratios to solve problems, you are doing trigonometry. Yay! Trig is awesome, and we're going to spend a couple days on this, so you're going to have lots of time to practice. A couple things before we jump into some problems here. We talked about sine, cosine, and tangent. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is the opposite divided by the adjacent. Now, please think about sine, cosine, and tangent of theta just as decimal values. They're just decimal numbers. That's all they are, okay? Now, the next thing I want you to see over here is this last box that we taught that is in the table here. There's these SOHCAHTOA over and over and over again. Well, what's going on here? So SOHCAHTOA is something that you'll hear a lot as you move on in math. And the reason why you'll hear it a lot is because it's a great memory device for helping you remember sine, cosine, and tangent. And I've seen students hundreds of times write it on the top of their page when they start to solve problems to help them remember what's what. So SOHCAHTOA, what does it stand for? Maybe you've already noticed, but basically it stands for, S stands for sine, and OH stands for opposite over hypotenuse. And here you go, C stands for, you guessed it, cosine, and then AH stands for adjacent over hypotenuse, and TOA, yep, tangent, stands for opposite over adjacent. So I can't recommend highly enough just trying to memorize SOHCAHTOA and write it down a couple times, write it on your homework, practice problems, wherever you need to in order to help yourself remember sine, cosine, and tangent. Okay, Mr. Kowalczyk, that's a lot of great information. I don't understand any of this. How are we going to use this to solve a problem? Well, that's a great question. Let's go ahead and solve some problems together. All right, now the first thing we're going to do is we're just going to write down the trig ratios for angle B with all of the information that we have, okay? Now, the first thing, in order to solve this problem, we know that we have to write the sine of angle B, the cosine of angle B, and the tangent of angle B. Now, sine, cosine, and tangent are abbreviated this way. When you see this, don't say sin. It doesn't sound right. It just doesn't. When you see this, you can say cos or cosine, and this is tan or tangent, but this is not sin, okay? Just try to avoid that. It doesn't sound right. All right. It also kind of makes you sound like a noob. All right, so here we've got the angle B right here. So this is our perspective as we talked about up here. So we're looking from angle B. So I'm just going to label my sides. My hypotenuse doesn't ever change. And opposite is going to be straight across from angle B. That's this side here. And then my adjacent side is the only one that I have left. And that's going to be this side right here, adjacent. Okay. Now, some students also in the past have told me that it's helpful to be reminded that the hypotenuse, well, no, we're not going to go there. I won't go there yet. All right, so now we've got angle B. So now I'm going to fill in what I know. So I know that the sine of angle B, well, angle B is equal to 25 degrees. So I can put the sine of 25 degrees is equal to the opposite over the hypotenuse. And then finally, the sine of 25 is equal to, well, my opposite is side B, that's right there, and my hypotenuse is side C, side B over side C. That's all the information I have, so I can't fill anything else out. That's my first trig ratio. Now the cosine. The cosine of 25 is equal to the adjacent over the hypotenuse, and then let's see if what information we have here. Cosine of 25 is equal to, the adjacent side is 8, and the hypotenuse is C. So I have 8 over C. That's all I can fill out right now. We'll get a little bit further on later on in the lesson, but that's how we would fill out that trig ratio. Our last one is tangent. Tan of 25 is equal to the opposite over the adjacent. And let's figure out what that is. So tan 25 is equal to the opposite, which is side B, over the adjacent, which is 8. And that's all we know. We're just asked to fill out, write all the trig ratios, okay? That's all we're asked to do. All right, let's turn the page. I'm not going to do number 2. I want you to do number 2 in class, but I am going to do a couple up here, okay? So we've got number 3. Let's take a look at number 3. Now, this is when we're going to need our calculators here. Use the trig ratios to find the value of the variable. Round to the nearest 10. Okay. Now, I've got my angle here, so that's going to be my perspective, where I'm going to be looking from. So I'm going to label the sides that I know. I know this is my hypotenuse, because it's in my 17 opposite of the right angle. And then this one here is going to be opposite the 54. So that's my opposite side right there. So now what I have is so, ka, toa, and I have opposite and hypotenuse. So which of these 3 is that going to point me towards? Well, OH is sine. So that's the trig ratio I need for this particular problem. You have to pick the trig ratio that you need. So I'm going to write that out here. Now, sine of theta is equal to my opposite divided by hypotenuse. All right, now stay with me on this. I fill in what I know based on these values. Now, theta is my angle. I know that. That's 54. So the sine of 54 degrees is equal to the opposite, which is W, divided by 17, which is my hypotenuse. Now I have to solve for my unknown value, which is W. So check it out. This turns into a proportion because sine of 54 is a decimal number, like I said, divided by 1. So we cross multiply to solve our proportions. Now we're going to get 17 times the sine of 54 equals 1W, or just W. All right, now what do we do with this? Well, remember earlier I said that the sine of 54, or the sine of any angle, or the cosine of any angle, it's just a decimal number. So this is when I get out my calculator. And the cool thing about your calculator is that in the calculator, they have a bunch of buttons and also a whole bunch of information stored in the memory of the calculator, with all of those decimal numbers already figured out in the memory of the calculator. So check it out. here's how we're going to do it. What we're going to do first is we're trying to figure out 17 times the sine of 54. But what I want to do is I want to show you the sine of 54 is just a decimal number. So you've been seeing these numbers on your calculators for many years up here, sin, cos, and tan. Those are sine, cosine, and tangent. So now what we're going to do is the first thing that we have to do is make sure that our calculator is in degree mode, okay? And I'm not going to go into how to solve that for all of them. So what I want you to do first off is I want you to do this. I want you to hit tangent of 45 and then close parentheses. And then hit enter. You should get 1. If you're in 1, that means you're in degree mode. So I'm going to zoom in here real quick. And right there, that says DEG. That tells me that I'm in degree mode. So your calculator should have that too, okay? Now, tan 40, if the tangent of, the other way to test it is to see if tangent of 45 is equal to 1. The tangent of 45 at 45 degrees is always equal to 1 as a whole number. That's just a mathematical given based on our trig ratio. So when you're trying out a new calculator from me or from anybody else, always test it out to make sure it's in degree mode by either seeing DEG up here and or testing tan 45, and that should be equal to 1. So now we know we're in degree mode. Cool. So why is this important? Because there are other ways to measure degrees, and I'm not going to get into it right now, but they're called radians and gradians, and that'll be later on. But don't worry about that for now. We just want to make sure we're in degrees, because the calculator can do those other methods also. If you're not in degree mode, look online and see how to turn your particular model of calculator into degree mode. And there'll be a bunch of tutorials about how to do that. Okay. Now, let's see what the sine of 54 is. So clear all that out. We're in degree mode. We're good to go. Now, sine of 54 is equal to 0.809, blah, 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 blah. There's a whole lot of decimals. It goes on and on and on. All we're really concerned with is the sine of 54 is equaling this. Now, the calculator has a whole bunch more decimals in it. We're going to forget about those. All we're going to do is we're going to take this decimal and we're going to multiply that by 17, and that's going to give us 13.75. Now, up here, it said round to the nearest tenth, which is 0.1. So we have 7 and 5. The 5 tells us that the 7 needs to round up to an 8, and therefore, W is equal to 13.8. But it's not. It's not, because we know that we cut off a whole bunch of these decimals and we rounded. So we have to use our approximation squiggly lines when we get to W. So don't forget that when you round, you have to approximate and make it equal to that. Okay, that was a lot for the first problem. Let's try another one here. All right, let's look at number 4. So now, same thing. This is our angle of reference or our perspective. So we know W and we know 4.5. 4.5 is opposite the hypotenuse, or opposite the 90, so that's going to be our hypotenuse. And then 33 is right next to W, right? The adjacent is right there. So this is going to be the adjacent. How do I know that? Well, if you're not sure which the adjacent is, look for the opposite and the hypotenuse, and the only one that's left over has to be the adjacent, okay? So that might be a way to help figure out which is which. Now, we've got the hypotenuse and the adjacent, and we look over here, and that points us towards cosine. Cosine, adjacent, and hypotenuse. So I'm going to write my ratio out. Cosine of theta is equal to the adjacent over the hypotenuse. Now I plug in what I know based on these values here. So cosine of 33 is equal to W divided by 4.5. Now, just like before, I'm going to cross multiply with my 1, and I get 4.5 times the cosine of 33 equals W. All right, now let's get our calculator out here, and we'll clear all this out. And I'm going to find out cosine of 33 equals 0.8 something or other times 4.5. What does that equal? 3.77. Those are the first 3 numbers that I'm concerned with. This 7 is bigger than this 5 or bigger, so it tells this 7 to go up to 3.8. Therefore, W is approximately 3.8. Now, one of the things that's important with trig is that because we're using a calculator and there's a ton of steps, it's really important to check for reasonableness. And what I mean by that is If I pushed a button wrong or I hit divide or whatever, and I get a wacky number, I got to check in my triangle to make sure that that might make sense. Now, if the hypotenuse is 4.5, we know that the hypotenuse is always the longest side of the triangle. Therefore, 3.8 for W makes sense because it's a little bit less than 4.5. All right, cool. So that's my reasonableness check. That's all I mean, to just make sure that you're doing it right. All right, let's do one more, and then we'll skip ahead to another section here. Okay, so this is my angle of reference here, my perspective. Opposite is going to be 10. Opposite the 90 is going to be my hypotenuse, and that leaves me with my adjacent left over. Okay, now I have adjacent and hypotenuse, and I look back at my ratio here, or my SOHCAHTOA. Adjacent, did I say adjacent and hypotenuse? I meant adjacent and opposite. I have adjacent and opposite. That's going to point me towards my T for tangent. All right, so I write my ratio out. Tangent of theta equals opposite over adjacent. Now I fill in what I know. Tan 25 equals opposite is 10 over adjacent, which is x. All right, now this looks different because in the other two problems, we had the variable up top. So here's what I want to show you a little trick. Remember at the beginning of last unit, we spent all that time memorizing the means and the extremes properties where you could switch things in proportions. This is when it comes in handy. So check it out. If I switch my extremes, the x and the tan 25, what I have now is x equals 10 divided by tan 25. And I don't have to cross multiply and do all that other stuff. All I want to do is get x by itself, isolate x. So then I can just go ahead and switch the means and the extreme, or switch the extremes. And now I have this, and I can do that in my calculator. It just saves me a couple steps. So let's do that. All right, clear this out. I start with 10, and then I divide it by the tangent of 25 degrees, which again is just a decimal. I hit enter. What that means now is that x is approximately 21.4. This 4 is less than 5, so the 4 over here stays the same. I check for reasonableness. If this side is 10, this adjacent side looks a lot longer, so 21.4. Yeah, that makes sense. I could deal with that. Okay, I'm going to stop there. We'll practice this again in class, finding the side lengths. Now, one other thing that I'm going to do, this video is not over yet. What I'm going to do here is the next page. We're going to look at using trig to find angle measures. Okay, this is the last topic that we're going to be working with today, but it is an important one. Okay, so don't slip yet. We still, if you need to pause it, take a break, take a couple minutes, and come back to the video, do that. But we got a couple more minutes and some more practice problems to do. Okay, I told you this was going to be a big lesson. All right, now you can also use trig ratios to find angle measures in triangles. Before, we were just finding the side measures, but now what we're going to do is we're going to find the missing angle measure using those trig ratios. So how do we do that? Well, you need to know how to undo the trigonometry to find that angle. I undo addition with subtraction. I undo multiplication with, you know where this is going, division. Now, what are these called? They're called inverse operations, right? You undo something by doing the inverse of it. And we use them to solve for variables all the time in algebra. We do the same thing in trigonometry. We call these inverse trig functions. Okay, what do they look like? They look like this. Theta, the angle that we're solving for, could equal the inverse sine to the -1 power, that's how we write that, of the opposite over the hypotenuse. Theta could equal the inverse cosine of the adjacent over the hypotenuse. Theta could also equal the inverse tangent of the opposite over the adjacent. And yes, we'll do 3 of these practice problems just to make sure we know what we're doing here. Okay? All right, let's jump in. Show you what this looks like here. So we're going to use the trig ratios to find the value of the missing angle. Round to the nearest 10th of a degree again. Okay. Now we're going to set the problem up the same way we did in the past, except the last step is going to be slightly different. So this is our angle of reference here, and I'm going to label all my sides. Now I know my hypotenuse is opposite my right angle. This is going to be my opposite, and then this is going to be my adjacent. Yeah, that's all that's left over. All right, so I have an 8 and a 5. I've got opposite and adjacent. So if I go back, let me rewrite it down here. So TOA, opposite and adjacent, that points me towards tangent. Okay. Now, just like I said up here, the theta, the angle in question, or in this case, the variable's x, is equal to the inverse tangent of the opposite over the adjacent. So let's follow that pattern. So I'm going to call it x. If you want to, you could write it out to help you practice and remember it. Now I plug in what I know. X equals the inverse tangent of the opposite side, 8, divided by the adjacent side, which is 5. Okay. Now we go back to our calculators and we use our handy dandy functions here. Now the thing that's different about this, I want you to pay attention to. Sine, cosine, and tangent are in white. In my calculator, sine, the inverse cosine, and the inverse tangent are above those buttons in green. Now, the cool thing about the green is you probably remember from doing some like square root stuff and others is that we have to push the green button, in your calculator, it might be blue or pink or whatever, in order to get up to those functions. So now what I'm going to do is I'm going to push second to get up to it, and then tangent. And yours calculator should, just like mine, say tan to the -1 or the inverse tan. Then I plug in what I have here, 8 divided by 5, 8 divided by 5, and I close my parentheses, and then I hit enter. Now, this 57.99, what this means is that the measurement of angle X is approximately 57.99 degrees. Okay, so just note that. When we do the inverse tangent, we're getting an answer that's in degrees, not in side length, right? Because we're finding the angle measurement. So the calculator is telling us what the angle measurement is. Now we have to round to the nearest 10th, which is this 9. This 9 tells that 9 to go up to 10, which makes this angle 58.0. X is approximately 58.0 degrees. Don't forget that degree sign. Okay. Let's try another one. 11. All right, now our angle of reference is here. That's going to be X again. I'm going to label my hypotenuse first. Opposite that is this side, and then all that's left over is the adjacent side, yeah? Okay, cool. Now, keep going. We're hanging in there, doing great. Now, I've got my hypotenuse and my adjacent side. Adjacent and hypotenuse points me towards cosine. So theta is equal to the inverse cosine of adjacent over hypotenuse. Theta is equal to the inverse cosine, or x in this case, is equal to the inverse cosine of 3.0 divided by 5.8. All right, calculator time. Second cosine 3.0 divided by, what is it, 5.8? Close parentheses, equals 58.85. That 5 tells the 8 to go up because it's 5 or greater. X is equal to 58.9 degrees. Perfect. Okay. Now, let's look at this one. This is my angle of reference. This is my hypotenuse. This is opposite. Okay, so I'm going to stop there. I don't need to label my adjacent side. I could, but I don't have to because 31 and 34 are my values. And then I look down here, opposite and hypotenuse points me towards sine. The inverse sine of is, theta is equal to the, I lost my place, opposite over hypotenuse. So then in this case, it's a question mark. So I'm just going to keep it as theta is equal to the inverse sine of 31 divided by 34. Now I want to show you something that could go wrong on your calculator, what you might see, right? So let's say you do sine 31 divided by 34, close parentheses. And you get a wacky number like that. So if you, this is another way like that you might check for reasonableness. So you might see what I did wrong. I just pressed sine. I didn't press the inverse sine or sine to the -1. So just be careful when you're doing your problems to make sure that you get the right, a number that looks right when you're getting the angles also. So let's try it again. Sine to the -1, 31 divided by 34, opposite divided by hypotenuse equals. There we go. Now we got a number that looks much better. 65.75. The 5 tells the 7 to go up to an 8. So then theta is approximately 65.8 degrees. Okay, that's how you use trigonometry to solve for angle measures. All right, I think that's it. Let me just double check. That's all I wanted to teach. I know this was a long video. It's a lot of information. We're doing this on a block day. So we'll be able to work through this and we'll do some practice problems before we start it in class. So, all right, yep, that's all I wanted to teach. Thank you for hanging in there. Good job. Like I said, if you can get a calculator, the TI-30 XSs are like $18, maybe $15 in the store. You can probably find them online on eBay for cheaper. You really don't need anything more than this all the way through the rest of your career at Fairview. So if you haven't picked one up yet, I can't recommend it highly enough. It's so good to have your own calculator. iPhones with trigonometry, it's just screwy and annoying and frustrating. So yeah, try to get one and see if you can make it work. Okay. All right. Have a good one. Good job. Hang in there.